This question 10, is a application problem. It's a rational function. We're trying to find the cost per day, or the function tells us the cost per day to remove X% of salt from seawater at a desalination plant. The function, the cost function, has a domain from 0 to 100. So let's just use that information to say, we're going to have to graph this. This is 50. And the inputs are X%, it's percent. The outputs of this function, and it says we want to do the output in the range 0 to $10,000. That's $10,000. And here's 5,000. So that gives us a scale. This is our cost in dollars. Now, and we need to graph this accurately. We include labels. So I've got labels here. And let's just do a little bit of what I would do on this problem is put this function onto my graphing calculator. Make sure you use parentheses. That's kind of why they're indicated here when you put it in, because you're going to put in the function, y1 is equal to, and if I were putting that on my calculator, I'd put in 994x, parentheses, and then parentheses again, 100 minus x. And then go ahead and graph it. Now the window is, go in there and x1 or xmin, go into your window, and xmin is going to be set to 0, and xmax set it to 100. And scale, you can see there are 10 divisions, so you could say x scale. I think it just says something like this. Scale is 10. Y min 0. Y max, this is what you'd put on your calculator if you wanted to see what this looks like, would be 10,000. And then Y scale, well, there are 10 divisions, so 10, 1,000. Each of those divisions represents, or each of these marks here represents 1,000. Now, I don't have a graphing calculator on my computer, but I've gone ahead and used a Desmos calculator and set it up so that I have these kind of scales. Now you notice it goes up by 2,000s here, but here are some points that are showing. Later on, we're going to have to answer, what is the result when x is 25? Well, there's our result. X is 75. You can do this with your calculator by graphing second calc value and just put these values in. We'll verify them here in a moment. But you could graph this. We see that at 10 it's 110. At 50 it's 994. Let's go back and do a little bit of this. At 50 it said it was 50, it was 994. 994 at 50 is just below 1,000, so I'm going to plot that point. And at 10, I was at 110, barely above the x-axis. Now, and then I'm going to go ahead and answer these for 25% and 75% and get a couple more points, because here's 25%, and here's 75%. So let's do these by hand, even though you could, once you get this graphed on your calculator, you can use the value feature to find those immediately. And that's quite all right, and I encourage you to do that. But C of 25. We can do this by hand, and it would be 994 times 25 over, now I'm going to, in 100 minus 25 is 75. If I put that on my calculator, 995 times 25 divided by 75, I'm actually going to just cancel this, and that's going to be 994 over, and what I divided out was 25, so that's over 3. So this is about 331.3, or just, it's right there. I mean, it's in that ballpark. C of 75 is equal to 994 times 75 divided by 100 minus 75 is 25, and these would cancel, and this would be times 3. 994 times 3, get a calculator up here. 994 times 3 is equal to 2982. 2982, or just a little below 3,000. So it's a point up here. Now it's a rational function. We don't expect a straight line here. Going back to the graph, we could calculate some more points. I did calculate 990, so if I want to remove 90%, I'm up to almost $9,000 for 90%. So 90% is here, up to, it's about $9,000. So a point like that. So my graph, and I want to be as accurate as possible, and it does this, and it's really curving up. And if we look at the graph, again, here's my point, 90, 89, 46, here's a point, let's see if we can get that, 2982, at 50, we have 994, here's the 25%, 331. So you see a curve like this. Now it does have an asymptote. The asymptote is when, here's the function up here, we can't divide by 0, so 100%, if I want to remove 100%, you can see that gives me division by 0, and impossible. So that's our graph. If we come back here and take a look at that, that's reasonably accurate. And we have that again off here on the right. That's a vertical asymptote, really, at x equals 100. Now, we need to find out, well, what's the budget? If the budget is only $5,000 per day, how much can we remove? That would be like saying, okay, well, this is as much as I can spend. How much salt can be removed? What percent of the salt? It looks like it's somewhere around, 87%. That seems to be about approximate. Well, we can solve this. Say 5,000. That's the budget, the cost. It's 994 x over 100 minus x. If I multiply both sides by 100 minus x, 100 minus x, what I get is 5,000 times 100, I got a couple zeros, minus 5,000x is equal to, these cancel, 994x. And add 5,000x to both sides. Add 5,000x to both sides. This cancels. And on the right hand side I have 994x is equal to 500,000. Divide both sides by 5,994. Divide this by 5,994. This cancels, and what we'll get is x on the right, and on the left 5,000, or sorry, 500,000 divided by 5,994. We get 83, about 83.4%. And that's a percent. So this this answer here, 83.4%, would be our result, and that is reasonable. Looking at our graph is reasonable. Now, if you were using your calculator, you could actually just graph this line, y equals 5,000, put a second function on your graph, and then look for the intersection. And there's the intersection at 5,000, 83.42. Finally, the question asks, according to this model, would it be possible to remove 100% of the seawater salt? Explain. The answer to that question is clearly no, because no. One reason is this would mean division by 0. It's not part of our domain. You could say that by 0. It's not in the domain. It would be infinitely expensive. You could put a lot of explanations, but essentially you should somehow reference the fact that, 100 isn't even in the domain. It's less than 100. You can't remove 100%, absolutely 100% of the salt, because the model says division by 0 would be the result. Impossible.